Expand each logarithm. For the exponents manual, we can look at different log properties, starting on page 15. Log base b of b equals 1. If you have the same base and the same argument, it's going to equal 1. Log of 1 will always be 0 here. And then if you had log of 0, that would be undefined. If you ever change a base formula, identity, be base b to, if you have b to the log b of x, that would just give you x. Remember, natural log has a base of e, common log has a base of 10. The log product property is adding the logarithms together. So to expand it, you start with log of something times something else, and then you would just expand it into 2 logs. Here's some examples. We have expanding and condensing. The log quotient property is subtracting logarithms. So you have a number divided by another number, or variables. And then you would separate it into 2 separate logs with a negative sign in between. Because remember, divide by y is the same thing as y to the negative first power. Here's your examples. The log power rule is you have a number on the outside of the log, and you can put it inside as an exponent. Or you can start with the exponent and put it on the outside. The condensed version is when the exponent's on the inside, and the expanded version is when the number is on the outside as a coefficient. And then we have our negative power logarithm property. And here's your examples. So from the handout, it's also on Canvas, useful exponent log properties. Here is a summary of the different properties. Condensing, expanding log properties. We have adding logarithms, subtracting logarithms, and then the power rule. This is the expanded version on the left side, condensed version on the right side. So let's look at number 88. We're going to expand this expression, log 5 of x squared over y to the 4th power. So the first thing we could do is use our power rule to move that 4 to the front. We can use our subtracting logarithms property. To separate into 2 different terms. And then we could move this 2 to the front using the power rule again to get 8 log base 5 of x minus 4 log base 5 of y. And that's our expanded expression. Let's go back through and write the properties. So we have power rule, and then we have a quotient property, and then we have the power rule again. Okay, let's look at number 89. Log base 8 of x times y times z to the 5th. So using our product property, we can separate this into 3 different terms. So we have log 8 of x plus log 8 of y plus log 8 of z to the 5th power. And then we can use the power rule to write that 5 at the front. So our expanded logarithmic expression would be log 8x plus log base 8y plus 5 log base 8 of z. And let's look at one more for this section. Log base 7 of the square root of x cubed. So first let's rewrite it as log 7 of x to 3/2. We're just rewriting the radical as a rational exponent. And then use the power rule to bring that 3/2 to the front. 3/2 log 7 of x. And this is your expanded form. So if we go back and do our properties, we rewrite the radical to exponential form and then the power rule. And then your answer. Okay, try more of these on your own, expanding these logarithmic expressions. Check the key as needed, and then move on to the next section, condensing logarithms.